Okay, so today's chapter is chapter 12, and that chapter talks about the concept which is called as fuzzy logic. So, fuzzy logic. Now, what is this fuzzy logic? Now, the word is sort of ambiguous, but let's try to understand what it means. Now, I will start with my personal example. So I did my undergraduate schooling in India, and there we had absolute grading system. So what it means is if you score 40 points out of 100, so if you scored 40 points out of 100, then you pass. Now, what it means is you could very well score 39 points, and that means you fail and you have to repeat the course. Now, interestingly, but if you score 39.5, that would be rounded off to 40, and then you will pass. So if you want to decide whether someone is passing a course or failing a course, this is a very crisp logic. If you cross this threshold, you pass. If you don't cross this threshold, basically you don't pass. So this is something called as the crisp logic. And clearly we understand the flaw with this crisp logic, because just sort of 1 or 2 points should not make a significant difference in person's knowledge. So why are we using crisp logic to measure or to assess a concept abstract, like an abstract concept such as knowledge? And humans, most of the times, what they do is they deal with this ambiguity. So I give you a simple example. Say, for an example, if I say I am almost hungry, but it's close to dinner time, and I would wait. Even though I'm almost hungry, but since it's 15 minutes or so, I would actually wait till the dinner is served. Now, you can see that almost hungry and close to dinner time, almost and close to, these concepts can be very well understood by humans, but computer or an algorithm cannot understand these boundaries, because these boundaries are not crisp, but these boundaries are sort of fuzzy. Now, fuzzy logic, there was a lot of development in the 80s and 90s in fuzzy logic. Fuzzy logic was considered one of the early algorithms or early approaches for machine learning, because the idea here is, and this is very important, something called as knowledge encoding. So what does it mean? Which means that humans have knowledge about the surrounding. Humans have knowledge based on the past experience. Now, unfortunately, the algorithm or a mathematical equation does not have that intuition or that background knowledge. So how do we encode this knowledge so that the computer or an algorithm can make crisp decisions? So what do we do for this is a very standard approach, wherein what you have is you have, say, decision variables. So for example, you look at certain variables, then based on those variable values, you make some decisions. So here is how human thinks. So for an example, here is a human being, and he gets some data. And based on this data, based on the prior knowledge, a decision is made. So for an example, it may rain today, so I'm not gonna go out. Or it may rain today, so I'm gonna grab an umbrella. Or which route to take. So this data is translated into a decision, but this process is ambiguous. So basically, this is fuzzy. So, but computer or algorithm cannot decipher this fuzziness in the data or fuzziness in the variable. So what we do is, here is a standard algorithm. So what you have is, you have variables or data that is used to make decisions. These are crisp values, which means, for an example, what is the temperature? 10 degrees. That's a crisp value. But is it too hot or too cold? It depends upon the person. So too hot, too cold is fuzzy, but the variable or the data point is crisp. Say, for an example, temperature, for an example, cost. So these are crisp variables. These crisp variables are converted into fuzzy variable by a process called as fuzzification. Fuzzification. So the idea is, these crisp variables are converted to some type of fuzzy variables. And then we apply some sort of logic, which is not a crisp logic, but sort of maybe not that type of logic. For an example, I'm almost hungry. That means I'm 50% hungry and 50% full. Or I could be 90% hungry, 10% full. Or in worst case, I could be 100% hungry. But if I'm 100% hungry, that means I'm hungry. It's not almost. So basically, we encode that almost, or that information that is ambiguous, into some type of fuzzy variables. So after fuzzy variables, what we do is, we have a fuzzy variables. So these are all fuzzy variables. And these fuzzy variables are basically fed into some type of a logic. So basically some type of logic. And again, this is logic. Even though it says logic, it's a very simple algorithm. Then once you apply fuzzy variables to fuzzy logic, you get a fuzzy decision. So now what do I mean by fuzzy decision? So I give you an example. I'm almost hungry, which means I'm 90% hungry and 10% full. So 90% hungry and 10% full. And my decision is, should I go eat or should I wait? Okay, should I go eat or should I wait? So this 90% hungry and 10% full is, we encoded this almost hungry statement into fuzzy variables. Like almost hungry means I'm 90% hungry, 10% full. Now these fuzzy variables need to go to a certain logic. So now, for an example, in this case, I would say logic, if you are hungry, you should go eat. If you are full, you should not eat. So basically, hungry means eat, and fuzzy full means not eat. So what that means is, there could be one-on-one correspondence, or there could be a function of the fuzzy variables. So for an example, if I say 90% hungry, which means I can say like that if I'm 90% hungry, that means I should 81% I should go and eat, and the 19% I should wait. So what happens is, 90% hungry, 10% full, I'm assigning these probabilities based on individual preference. So my preference is If I'm 90% hungry, I should go and eat 81% of the times. Or if I'm 10% full, then I should wait for 90% of the times. Alternatively, I can make my life easy and I say if I'm 90% hungry, then most likely 90% I should go and eat, or 10% I should wait. So what happens is, basically I have encoded my fuzzy variables into some combination of fuzzy decision, and based on this, what I would do is I would render a fuzzy decision. A fuzzy decision is something like, if you are 90% hungry, 10% full, which means you should go eat 90% or you should wait 10%. And then this fuzzy decision now since needs to be converted into a crisp decision. So finally, this is the crisp decision, because that's what I want to do, whether I go eat or whether I don't eat. So what I do is I take this fuzzy decision, convert into crisp decision, and then that could be converted into action. Now, this sounds like a complicated process. It's actually not. It's very simple. And the idea is, how do we mimic the human decision behavior into an algorithm or an approximation that a computer can understand? And fuzzy logic, believe it or not, works very well on a lot of applications. For an example, finance, fuzzy logic works. Then banking, fuzzy logic works. As a matter of fact, if you look at the control system in robotics, fuzzy logic works. You can aid fuzzy logic with neural network and construct something called as a neuro fuzzy system. And then basically that you would actually encode the knowledge, or you represent the knowledge, and then use that knowledge, feed that through a neural network, and then get a decision. So for an example, the logic here, what you see, that could very well be represented by a neural network. Because what would a neural network do? Neural network is a universal functional approximator. It will take the variables, it will render the decision. So basically, or you can just use a simple regression. So you can play a lot more tricks in this workflow. But let me explain you in simple words how this whole concept of fuzzy logic works. Let me take an example. And the example that I'm going to take is credit score. And risk. So credit score is a number between, I think, 200 to 850. That is used to decide the credit worthiness of a person, which means basically if you have paid your bills on time, you don't have any outstanding loans, if your credit cards are all current, no delinquent or any other issues, then your credit score would be very high. So, and clearly there is a risk. So for an example, if you apply for an auto insurance, so auto insurance company want to understand whether the person I'm insuring is a risky individual, or basically a sort of a medium individual, or no risk individual. So basically the risk categorization is high, medium, and low. And the credit score is also characterized as high. And I'm going to call high credit score maybe 550 to 750. Medium, which is maybe 350 to 550. And low, which is less than 350. So 0 to 350. Now, one classic way of doing this is I can have a one-to-one correspondence. So I would say if someone's credit score is high, basically the risk is low. If someone's credit score is medium, the risk is medium. If credit score is low, risk is high. But there are a couple of problems with this. For an example, high for me may not be high for you. So for an example, maybe Geico would give you a good insurance for your credit score, but Progressive may not. So every insurer uses different guidelines because they have their different experiences based on their insurance claims and all that. Then again, to me, high risk is maybe if someone is going to default more than 75%. So default risk is 75%. For someone else, he would say, no, I'm just gonna do prime and my default risk is 65%. So every lender, every insurer, so basically they have these fuzziness in their decision. So right now we have this credit score, which could be high credit score. Now here is the question. So if I were to plot something like this, now this is where the fuzzy logic shines. If I say risk, or if I say credit score, so credit score, and if I say risk, what that means is if I have a high credit score, then my risk is low. If I have a medium credit score, then my risk, no, actually I made it opposite. So basically, if my score is high, somewhere here, then I think this is better. So score risk, which is high, medium, and then there is low. And this is score. So if my score is between 0 to 350, my risk is high. If my score is between 350 to 550, my risk is medium. And if my score is above 550, then my risk is low. So you can see that these are sort of the crisp boundaries. But the problem with the crisp boundaries is, please understand, there is this region where things are sort of ambiguous. So for an example, if someone is sitting right here, what does it mean? Is it high risk or medium risk? If someone is sitting right here, then whether it is low risk or medium risk. So basically what it means, as these thresholds, crisp thresholds, are not very useful when we are trying to capture the information about past data or your knowledge or your policies. So what we want to do is, we want to come up with some type of system that can take this information about high, medium, low scores and also take information about the risk and then potentially encode that information into some kind of a logic or algorithm that will take all this fuzzy information and at the end will tell us that, okay, this is, if this is the credit score for this person, this is the percentage risk of failure or percentage risk of default. So let's try to understand how these rules are formed. Now, typically what happens is, whenever you are trying to form the rules, please understand this is knowledge encoding, which means based on the experiences, the knowledge is gained. All that knowledge is sort of distilled and kind of put into rule forms. So for an example, if I want to decide, what I would do is, I would interview maybe 5 or 6 auto insurers and then ask them, hey, what is a good credit score for you? Geico would say, good credit score for me is maybe 600 to 850. Progressive may say it's about 550 onwards. Maybe American Family Insurance would say, no, our credit score has to be more than 600. So you have these variations, but one thing is clear, that if someone's credit score is going to go below 550, that means that that is clearly not, okay, that is clearly not a high credit score. It is somewhere in between medium. So what I'm going to do is I'm going to construct something called as membership functions. So how does this membership function look like? So this is credit score of 0. This is credit score of 350. This is credit score of 550. And this is credit score of 750. So we know for the fact, so this is the threshold. We know for the fact if someone's credit score is more than 750, if someone's credit score is more than 750, then what that means is that clearly is a high credit score. And farther you go away from 750, then your credit score is considered higher and higher. So I'm going to encode this into some type of membership function, something like this. So the idea is the membership function actually is going to tell me that if the credit score, as the credit score, so sorry, 550. So as the credit score goes beyond 550, as the credit score goes beyond 550, clearly that person is going to be a good credit person. So basically this is the high boundary. And then what I'm going to do is I'm going to do the exact same thing for low. So I say that if the credit score is below 350, then clearly that person is going to be a low credit score. So basically something like this. So this is, so clearly this tells me that, and I want you to understand, this is where the crisp boundary comes in. So clearly in this region, the credit score is low. Clearly in this region, the credit score is high. But now the question is, when someone is between 350, okay, to 750, what happens then? Or what happens if someone is in this region? So let me see if my boundaries are correct. So 350, 550, 750. Yeah, 350 is the lowest. So this should be 550. Should be 5. So now what that means is basically at 350, it's you are clearly less than 350, you are clearly in the low credit score. More than 550, you are clearly in high credit score. The problem is what happens when you are in this region. So what you do is basically we actually assign a membership function here. So something like this. Now this membership function, you can consider this is to be maybe 1 and this is 0. So now what that means, and let's understand what it means. When your credit score is between 0 to 350, you clearly are in low credit score. When your credit score is greater than 550, you are clearly in high credit score. The region of ambiguity is when the credit score is between 350 and 550. The credit score, when someone's credit score is between 350 and 550. So I just want to give you an example. Imagine someone's credit score is maybe here. Someone's credit score is somewhere here. Now, if someone's credit score is here, then what that means is essentially that person that person has 50% or 0.5 low credit score, and then basically it could be 0.5 high credit risk. So basically what it means is we have fuzzified this input. And what you do is you actually look at many lenders or many insurers and then come up with these boundaries. I have drawn a vertical line, but again, you are not restricted by the vertical lines. You can actually use some type of a tan H function, or you can use a Gaussian function and kind of smoothen the edges. Now, the next thing is I need to encode the information about risk. So I need to encode the information about risk. Now, what I would do is I would do the exact same thing. I would go to all the lenders and say, what is high risk for you? So someone would say high risk for me is definitely greater than 75%. What is medium risk for you? Medium risk is between 50 to 75%. And what is low risk for you? Low risk is less than 50%. So what I'm going to do is, again, I'm going to encode this high, medium, and low risk kind of information just like this. So I would have, and I can use some type of a membership function that actually allows either a linear interpolation, or basically you can have a sort of a Gaussian interpolation or some other interpolation that data or your experience tells you. So what you have is you have something like this now. And again, sometimes just to make life easier, you can actually add something like this. So these are the membership functions. Now I'm going to say if it's greater than 75%, it's high risk. If it is less than 50%, it's low risk. So this is low risk and this is high risk. Now what I want to do is I want to take an example where someone, maybe a person, credit score is in between 350 and 550. If someone's credit score is between 350 and 550, say if the credit score is, let's say, somewhere over here. If the credit score is somewhere over here, so maybe this is 400. Now what I'm going to do is, now I want to find out this person whose credit score is 400, what is the risk? If the person whose credit score is 400, what is the risk? Now please try to understand. Somebody may say that, why don't I just interpolate? So something like I take 350 and 550, about 200 points, and I map it to somewhere in between 50 and 75, which is 25%. Why don't I just do an interpolation? Why can't I do the proportion? The problem with the proportion here is because the decision boundary is not crisp. And for an example, we interviewed a lot of lenders, and then we came up with these encoded knowledge. Like we know that some lenders, they are comfortable with credit score slightly greater or less than these boundaries, and they consider the low and high risk. Again, those boundaries are different for each lender. And now what we do is we take this information and come up with this knowledge encoding. And now the system, the algorithm gets asked this, like, I have a person with credit score 400. Now, if someone's credit score is 400, what is the risk percentage? So if someone comes to me with credit score of 400, what is the risk percentage? So what needs to happen is, I know 400 credit score is in between medium. It's a between low and high. It's medium. Now, what degree of medium, that I don't know, but I can say that since this is 350 is close to 400, clearly I would say this is maybe 0.2. This is 0.2 and this is 0.8. So I have 0.2 and 0.8, which means now the person who is in medium basically has 0.2 and 0.8 distribution between the low and high risk. So for an example, what it means is, if you have a credit score of 400, and this is very important, if you have a credit score of 400, that means you are 0.8% high, 0.8 high risk, and 0.2 low risk. So what has happened, this ambiguous statement, which was medium, now I encoded that into, if you have credit score of 400, which means you are 0.8% high risk, and then you have 0.2%, 0.2 low risk. Now what I'm going to do is, I'm going to take this information 0.8 and 0.2, and then I'm going to come up with some type of logic. Say for an example, a simple logic is, if someone has 0.8 high risk, I mean, sorry, 0.8 is a low, no, it's low, 0.8 low score, and 0.2 high score, because we are dealing with score. So this is score. So please understand, 400 of credit score means 400 number is encoded as 0.8 low and 0.2 high. Everyone understood this? Now what I want to do is, I want to translate this score. So here we have score. Here we have risk. Now I want to encode this score into risk. So what I'm going to say is 0.8% low score. I would say, again, this is just the logic that you define. You can have some combination, algebraic equation, perhaps a neural network that would take these two numbers and give you some fuzzified output. So 0.8, I'm going to say, if someone has a low score, then I'm going to say high risk. Someone has high score, that person has low risk. Now here I get a score of 400, which is 0.8 low and 0.2 high. So what I'm going to do is, I'm going to draw a line which is going to be 0.2 low. So basically 0.8 low and then 0.2 high. So I'm going to draw a line which is going to be something like 0.2 low, 0.2, and then I'm going to draw a line which is 0.8 high. Now please understand, now this is actually my region that I should be focusing on. So basically, now what I have is, if I were to look at the profile of this whole thing, I would say that I am somewhere in this region. And basically what I do is I actually construct this region. Now what that means is I am in this region. And what I would do is I would find the centroid of this region. And clearly, as you can see, the larger shaded area is on the high side. So once you find the centroid of this region, you would see somewhere, maybe I'm just guessing here, somewhere over here. And say this is 70. So what that means is based on the low score, high score transition from 400, converting that low score is like high risk, high score is low risk. I actually added those thresholds, which are 0.8, 0.2, that I encoded from my score onto the risk. And then I found the centroid of my pattern, and that centroid is at 70. So I can say if someone has 400 credit score, then probably he is 70% risky. Clearly, score is in between low and high, so which is medium. So risk should also be somewhere between medium, but this allows me to translate a score that is actually a crisp input into a fuzzy variable using fuzzy decision logic, and doing defuzzification and finding out the final value. And this may look a little bit complicated, but at the end of the day, what you do is there is a fuzzy logic toolbox inside the MATLAB wherein you construct these crisp rules. And then at the end, that toolbox will generate a C code for you that can be used for your controller system, or that can be used for your decision-making variables, and so on and so forth. Now, what is the alternative to fuzzy logic? Alternative to fuzzy logic is adding bunch of if, else, then type of statements, and then checking depending upon what options you have. But if you look at that whole code, then that algorithm, if you were to just add if, then, else type of statements, that will become super duper complicated. With fuzzy logic, you are encoding the past knowledge. You are encoding your inference, like what decision, what type of decision a human would take, and then use that information to assess the output. Yeah.
So the 0 to 1, the 0.2, 0.8, is that the probability that that score belongs in the middle?
Yes. So basically, if you are in the, if your credit score is 400, that means most likely your credit score, it belongs 80% it belongs in the low side, and 20% it belongs on the high side.
But is that flipped though? Because it doesn't make sense if it was 80, because if you go to a lower score, then there's a higher probability.
No, the low score. No. This is so okay. There are two encodings. One is the encoding of the score, and second one is the encoding. Oh, yeah. I made a mistake here. So this is low. This is high. No, this is correct. This is high risk.
Well, because if you took like the 350 point, right, or somewhere before the 400 on that graph.
Yeah.
And the top half gets smaller.
Yeah. So basically, if so, what that means is if you go here, it goes here. If you go, you're on 350, which clearly means your score is 100% in low region.
Okay, but like between that.
So if you are in between that, say 400, that means
375, I guess.
Okay, if you are in 375, somewhere here, then probably you are going to be like say 0.15 on high side, and remaining you'll be on the low side. So basically, that is how it is. So what I did, and then, so basically, this is the rule that engineers or you decide. I'm just saying low score means high risk, high score means low risk. But it doesn't have to be something like that. It can be like, you can say low score means basically you can make this a little bit more complicated by adding some type of an equation. That's also possible. You can also add the Gaussian membership function, not the triangular and crisp membership functions, and then basically come up with the risk. Another classic example is students' grade and the IQ. So for an example, common logic is one may say that, hey, if someone's IQ is high, then most likely that person's grade are going to be great. But we understand that it takes a lot more than just IQ to score good grades. That person needs to study, that person needs to open the book, it needs to understand the material. Then that person needs to take the quizzes and exams properly, needs to turn in the work on time. So all this is, there is a lot of ambiguity in all these. So what you can do is, rather than using just one score, one parameter, you can see different parameters and look at the so for an example, if IQ is high, attendance is low, still you will know that based on your experience the grades are going to be good. If IQ is low but attendance is high, based on your experience as a teacher, you can say that, hey, that person came to every class, worked hard, did the work diligently, so his grade is going to be good. So instead of just one score variable, you can have multiple inputs based on your experiences, and then you can actually perform the falsification on all those inputs, all that data set, and then take that information, feed into some type of inference logic, and find out the fuzzy decision. So for an example, the fuzzy decision in this case is, if someone's score is low, then the risk is high. If someone's score is high, then the risk is low. So you can use that fuzzy logic to find the fuzzy inference, and then finally you can use, there are different techniques. There is a centroid technique, and there are again other mathematical algorithms that would allow you to find out the converting the fuzzy decision into a crisp decision. Then you can, but centroid is a very commonly used technique, and if you use MATLAB, different techniques are available to you. And then what you can do is, you can actually convert a fuzzy inference into a crisp inference, and then accordingly you can decide the action. So this is the gist of fuzzy logic, and if there are any questions, I would be happy to answer. If not, I would encourage you to quickly look at the MATLAB fuzzy logic toolbox. And if you open MATLAB, there is this fuzzy logic toolbox. Okay, let me see. Some question. Yeah, it's similar, but Bayesian is based on so if you look at the Bayesian concept, it's based on, okay. Everyone familiar with what Bayesian algorithm or Bayesian logic is? So basically what it is doing is looking at the probability of something happened and the probability of current situation, and then use those probabilities to find the posterior probability of what's going to happen. In fuzzy logic, you are not using the Bayesian logic. What you are using is, you are using the own knowledge, what you have studied or what you have, to find out the information about the situation. And again, there are similarities and there are differences, but Bayesian classically or Bayes theorem is based on the probabilities and the joint probabilities. But in fuzzy logic, again, you are kind of using your heuristic, not the crisp mathematical logic to find out the probabilities. So that is the, and again, the thing is, Bayesian, it's Bayesian techniques have received a lot of attention, but there are non-Bayesian techniques. They also work quite well. So if you are interested, I would encourage you to look at the non-Bayesian technique, wherein there are a lot of cases where the rules of the probabilistic rules, the Gaussian distributions cannot be assumed. And at that time, non-Bayesian types of techniques give you better result compared to the Bayesian techniques. Okay, with this, I'm going to stop here. And if you have any questions, I would be happy to answer. But next class, what I will do is, I will go through the theoretical background of fuzzy logic. And then I will try to show you how you can use fuzzy logic inside MATLAB to solve a problem. And fuzzy logic, I have used it a lot for avionics applications. I've used it for motion capture. And believe it or not, fuzzy logic works very well when the situation is conducive for fuzzy logic. So fuzzy logic is not the logic that you will use everywhere. Sometimes the crisp inputs, for example, state flow diagrams, where the inputs are, so one is on or off. There is no in between. So in that case, you don't want to do a fuzzy logic. So basically the states, transition diagrams or state flow works very well when you have distinct boundaries. But when humans are involved, when the decision boundaries are not so clear, then at that time, the fuzzy logic can work very well. With that, I'm going to stop here, but I would be happy to answer any questions you may have. Next class would be the last class. And hopefully I'll see you there.